So, we're going to start today's session. So, first I'm going to recap for 5 to 10 minutes what we have seen in the previous sessions, and then we can continue with today's session. So in the first session, that is in the demo session, so the three topics we were discussing. One is what is an in-memory database, what is column database, and what is massively parallel processing. In the second session, we were discussing about the landscape and how these systems are interconnected to each other, and what is the username and password for each of these systems. So yesterday, that is Monday, yesterday was the first session that I delivered. So in the first session, once we log into SAP HANA Studio, what is a catalog? The first thing we see is what is a catalog. A catalog is a collection of schema. Under these schemas, we have a database objects like tables. These tables, SAP has designed the software in such a way that these tables, the primary way to store data is in memory. It's on memory, not on disk. These tables store data in columnar database, columnar fashion. So both in-memory and columnar gives advantage to access data faster. Under the catalog folder, we have seen another folder called content. Content. In the content folder, we create package. Now, what is the use of a package? Excuse me. Packages are used to group together related information. For example, all sales related information, we keep it in one package. All the FI related information, we keep it in another package. So packages are used to group together related information. Under these packages, we can create information views. So how many types of information views we have? There are 3 types. But what is an information view? A view is nothing but an object. A view is an object that gets data in runtime. So when the end user query on the view, at that point of time, it goes to these tables. Now, where are these tables? Where are these tables organized? The tables are organized under schema. Now, where is the schema? Schema is organized under catalog. So catalog, under catalog, you have schemas. Schema is used to organize database objects like tables. Now, how do we organize schema? The schemas are organized based on data provisioning method. One schema can have tables related to SLT. Another schema can have tables related to BODS. So schema is basically to organize database objects, and package is to organize information views. An information view, a view is nothing but an object that can access data in runtime. But where is this data located? Data is in memory. Data is organized in such a way it is stored in a columnar fashion. So simply to say, once you log into HANA Studio, you see system. Once you expand system, we see catalog and content. Catalog is a collection of schema. In schema, you have database objects like tables. In content, you have packages. Under package, you have information views. These information views are of three types: attribute, analytic, calculation view. So let me log into the system. So let me first log into the system just to show you. Just I'm trying to do a quick recap from the yesterday session. So once we log into the remote desktop connection, so now we can Hi Bharat. Bharat, are you there? Hello Bharat.
Yes, sir.
Can you basically ask the administrator to do a quick check on the system? I'm unable to connect.
Okay, sir. Okay, sir.
Okay, so meanwhile, I'll just continue the recap session. So meanwhile, Bharat will actually check on the remote. I'm unable to connect to the system. So, so we were talking about system. Under system, you have catalog, content. Catalog is a collection of schema. Schema is a collection of database objects like tables. Content is a collection of package. Under package, you have information views. Okay. So once we know, we have three types of information views: attribute, analytic, calculation views. Now, what is an attribute view? And what is the purpose of an attribute view? Attribute views are used to join master data tables. If you see, data is organized, data, business data, is organized in tables that store master data. It is organized in tables that stores transaction data. Now we know generally when we talk about data, data is organized in the form of tables. Data is organized in the form of files. Data is organized in the form of photos or videos. Even photo and video is also a data. But when you organize data in a form of a table, it is structured data. The data is structured in the form of rows and columns. When you organize data in a form of file, it is known as a semi-structured data. When we talk about semi-structured data, for example, newspaper, the daily newspaper that we get, the data is not organized in the form of tables. It is a semi-structured organization in the form of files. Also, data can be organized in the form of photos and videos. Okay, so now structured, semi-structured, unstructured. When we talk about semi-structured data, example is a newspaper. When we talk about unstructured data is nothing but photos and videos. Now, what scenarios can HANA handle? Excuse me. What scenarios can HANA handle? It can handle data in tables, it can handle data in files, but it cannot handle data to process from videos or photos. Now, why do we have to analyze data stored in the form of a video or a photo? For example, in a CCTV footage, you want to analyze what is the peak hour of traffic in this particular area. At what times the traffic gets peak. Accordingly, you want to organize the traffic very smartly. Nothing but the concept of smart city. So according to the times, the traffic signal should change. According to the time when the traffic is peak, you should automatically organize these things. So for that you need to analyze data in the form of CCTV footage or the form of photos. So this can be done using Hadoop. There is another system called Hadoop. Hadoop can actually do all these things. So we can integrate Hadoop to HANA to process unstructured data in Hadoop. We can take data from Hadoop and process in HANA. Now, what kind of data can we analyze for a semi-structured data? For example, there's a new movie released into market, or a new product is released into market, or about to release. It is released or about to release. You want to do the sentiment analysis on a product, whether the reviews are good for a product or reviews are bad for a product. Now, where can we get these reviews from? Can we get from Twitter, where different users in the Twitter account will actually tweet from different geographical locations from India? When an new iPhone is going to get released, what are the new features it has? So people will start tweeting about these features to analyze the sentiment analysis of a product. So you can analyze based on a geographical location whether you are getting positive tweets or negative tweets. Now, if you're getting more negative tweets, obviously we will delay the product release. Even before the product is released, we'll actually hold the product because a lot of negative tweets are coming from the geographical location. From another geographical location, every tweet it is coming, most of the time it is positive. So we can do sentiment analysis on a product for a semi-structured data, like data from Twitter. We can also ask questions: who are my top customers? Or what is my net revenue in this particular quarter? So these kind of questions we can ask in tables. There are questions you can ask on semi-structured data. You can also analyze data from videos and photos. But HANA can handle structured, semi-structured, unstructured data. It has to integrate to a different system. Okay. Now, now we know data is basically structured, semi-structured, unstructured. Structured in the form of tables, semi-structured in the form of files, unstructured in the form of photos and videos. But all these three things we can do analysis. And based on this analysis, we can take decisions. Now, yesterday, when we were talking about an attribute view, again, this structured data that we organize in the form of tables. The data is stored as master data and transaction data. Now, what is master data? The master data is a data that is not going to change frequently. So where can you actually do modeling for master data? Nothing but an attribute view. So attribute views are used to join master data tables to each other. For example, you can create an attribute view for customer. You can create an attribute view for material or a company code. So to create master data, to do master data modeling, we use attribute views. So yesterday, if you remember, we have taken one requirement. The requirement is, I'll basically continue the yesterday session. So from where I stopped yesterday, I just continued today from the same point. So in yesterday's session, so is my voice clear? Everyone is able to, is there any disturbance in between? Just to know, because I saw a few comments, the voice is not clear. Okay, thank you. Okay, so we continue. So, so in the yesterday session, we actually, if you see, we sit with business, we understand the requirement, we understand the requirement in a place called workshop. Once the workshop is completed, we basically document everything in functional spec. So we have taken one functional spec yesterday. So this is our functional spec yesterday. Okay. So this is what we have taken yesterday, where we can have different business entities, like, just take one big customer ID, name of the customer, region, name of region, country ID, and name of the country. So this is one requirement, and then you have another dimension called material. You have another dimension called material. Material ID, name of the material, metal group, and name of the metal group, and so on. And then you have transaction data. Transaction data, gross revenue, net revenue. What is my net revenue? So let us take the first one. So assuming that this is our functional spec that business has given to us. So we'll take the first one, this requirement. Let us try to analyze this requirement. Now, what should we build here is, what we need to build here is, we need to create this requirement in an attribute view. Now, why only we need to choose to create an attribute view? Why not another view? Because you see the data that we see here, this data that we see is not going to change frequently. I mean, the customer is not going to change every day to live in a different country or to live in a different region. So this data is nothing but the master data. And yesterday we also seen the master data is subclassified into three. One is attributes, the second one is text, and third one is hierarchy. Now, if you see this requirement, once you see this requirement, we should able to understand whether these are attributes, whether this is a text, or whether this is a hierarchy. So first we need to know from here, from the given requirement, what is an attribute, what is a text, and what is a hierarchy. Now please tell me, customer region. Which region does customer live? This is nothing but which gives more details about customers. Now, where are these customers living? In which region? Or which country does these customers live? So, region and country is giving more details about customer. Okay, so these are nothing but attributes. So, region is an attribute of a customer, and country is also an attribute of a customer. But what about name, which is nothing but the description? Now, this name is description. So, we can have one region name stored in different descriptions. Like you can store in Japanese, you can store in Chinese, you can store in English. So descriptions are basically text because you can store these descriptions in different languages. You can store these descriptions in different languages. And there is no hierarchy over here. So we don't see any hierarchical relationship, and we don't want to represent this data in a hierarchy. So we have attributes like a region, country. You have text like region name and country name. Now, this is nothing but the functional spec. The next thing that we need to do is convert this to a technical spec. Convert this to a technical spec. So in a technical spec, once you do a conversion from functional specification to a technical specification, the most important things in technical spec is, the first thing is, what is the source of origin for this data? From where are we getting this data from? What is the source? Whether this data is coming from a CRM system, whether it is coming from ECC, whether it is coming from a non-SAP system. We need to know what is the source of data. Okay. Let us say this data is coming from ECC, which is nothing but an SAP system, which is known as Enterprise Core Component or Central Component. Okay. Now we know the source is ECC. The next thing is, this data is coming from what tables? Because the data is organized in the form of tables, we need to know the origin of data. Which table can we find this data? Okay, let me copy this. Let me copy these business entities. So these are nothing but the business entities, and these business entities are coming from what tables? Now anyone who is working in SAP can simply say, the data that we see here belongs to customer, and customer related business entities are stored in a table called KNA1. So if you ask me, the customer ID is stored in a table called KNA1. The name of the customer is stored again in KNA1. A region is stored in the table KNA1. A region name means the description. This is nothing but the description. The region description is stored in a table called T005U. So this is a description table, nothing but the text table. Country ID is stored again in KNA1. The name of the country is stored again in a text table. The name of the text table is T005T. So now we know the columns and the tables where this data is stored. Now once we get this tables information, the next thing that we need to know is what columns inside these tables. Now each table may have 100 plus columns. So we need to know for each of these tables, customer ID is stored in KNA1 in which column. Now, let us say if you don't know this information, what we need to do. Let's say you're completely new to SAP. You don't know what is SAP, but you know what is HANA. We need to do coordination work. So you need to coordinate. If business is already using SAP, sometimes if we don't know the origin of these columns, we may directly ask business. So can you show me where do you see this column? So in SAP we have something called F1 function. So if once you click on F1, at least you can get some information where this column is stored, whether it is stored in a table, whether it is stored in a structure, or we can ask our colleagues, or we can directly go to Google. In Google we have a lot of documents, or we can go to help.sap.com, or we can, there is a community.sdn.sap.com. We can do trace. So there are different ways to get this information. But all this work that we actually do is even before actually start building. We don't even log into SAP HANA. First, we need to get these documents ready. And these documents can only be ready only through coordination and only through communication. So most of the time, it is really not possible to remember all these tables because in SAP there are more than 1 million tables, and each table at an average, if you see, there are more than 50 columns. So really not possible to memorize all these tables, but only through coordination we can get this information. So later I will tell you a few tips and tricks. I also prepared a documentation on how to actually find these tables for a given requirement. I've kept in the Dropbox. But now, because I'm already familiar with this process, so I'll just write down. So usually, whatever the documents that I'm actually doing this, more than knowing SAP HANA, we need to know SAP systems. So when preparing these documents, we don't have to know, even we don't have to know what is HANA. We just need to know how these SAP systems work and how these tables are interrelated to each other. Now, who is actually more, if you ask me in a project, who is more familiar with this process? ABAP. People or the consultants who are already working in ABAP have the greatest advantage to move to HANA because already they know how actually to get this information. Or a senior consultant, the consultant who is actually very familiar about a specific industry, whether it could be utilities, whether it could be CRM, whether it could be any other system. So usually in a project, these documents are actually prepared by senior consultants. Now there are consultants who actually work on little junior. For example, associate consultant. He may be very familiar with HANA. He knows the best practices to do data modeling. He knows how to do performance optimization. Everything technically he can work. But mapping the business requirement to system is little challenging for him. It's not that he cannot do, he can do, but only through coordination he can actually get this information. But senior consultants who are already familiar, they can easily complete this documentation and give to the associate consultants or a consultant. Okay, now let us go back. So customer ID in Kenya 1. So in Kenya 1, what is the column? KUNNR. Name 1. In Kenya 1 table, what is the column? Name 1. Regio. Region. So region is nothing but regio. Regio is the column name. And name of the region in T005U. In this table, what is the column name? BEZI. Country ID, Kenya 1, land 1. Country name, T005T, land X. Now, from the technical point of view, from the technical point of view, for a given requirement, so this was my requirement. For a given requirement, I know what is the source, what is the table, and what are columns inside these tables. Now, once you know tables and columns inside these tables, now what is the next thing that I need to do is, I'll just try to create few data flow diagrams. These are nothing but these are known as low level design documents. These are known as LLDs. Low level. A low level design document will contain very detailedness about how we are actually going to build this data model. It will contain the design. So in these data models, what are the different business entities I have? How these business entities are related to each other. Okay. So in here, to create a low level design document, how many tables we have over here? KNU1 is one table. KNU1 is one table. T005T and T005U. So we have three tables together. To achieve this requirement, we have three tables. So I'll draw these three tables over here. One is KNU1 table, T005T table, and T005U. So KNU1, T005T, and T005U. So from KNU1 table, what are the columns I require? What columns I require from KNU1? KUNNR, name 1, regio, land 1. So these are the columns I require from KNU1. What columns I require from T005T? From T005T, I require land X. From T005U, what column I require? BZEI. BZEI. So what am I trying to create over here is I'm trying to create an attribute view. AT underscore customer. So even I'm going to give the naming convention. Okay, this is the technical name of an attribute view I need to create based on a naming convention. And inside the attribute view, this is the design I need to have. So we have three tables. We need to know what table and what columns inside each table. The next thing is, once we know what tables, next question, how these tables are interrelated to each other. That is the next question here. How do we join these three tables together and achieve this requirement? So first thing is, what tables are necessary? Step number 2, how these tables are interrelated to each other. Now how these tables are interrelated to each other is, from KNA1 to T005T, what is this? This is nothing but country ID. This is country ID. The column that we have over here is country text. So how do I join both these tables together to get what is my country ID and what is my country name? So the relation between KNU1 and T005T is, excuse me, you can join both these tables land 1 to land 1. So when you join land 1 to land 1, you can get country ID and the associated country text, which is land X. So what is the relationship between KNA1 and T005 view? So here you have regio. In here you have a column called bland. So when you join, so regio is basically same. Regio is nothing but bland. Just the technical name is different, but the business data and the business entity is same. So when you join regio with bland of T005 view, you can get region description. We can get region description. So I'll give a simple example. Let's say the customer ID is 001. His name is John. The region that he belongs to is 08, for example, because 08 is nothing but region ID. The land one he belongs to is D. Again, this is also an ID. But what is D? How do we know what is D? D is nothing but Germany. So when you join D of KNA1, which is D of T005T land 1, when you try to join land 1 of land 1, D and D, land X is Germany. And in Germany, what is the region that customer lives? Where does John live? What is 08? 08 is nothing but Baden. So Baden is one of the region in Germany. So what are we trying to get here? 001, name is John. His region is 08. He is from Baden. His country is D. He is from Germany. So this is the sample data. So whenever we are working on an example, we also need to have sample data for it, because once we complete this data model, we need to prepare a test case, which is known as unit test. So in order to do a unit test, once we join these tables together, the desired result, what is my desired output? So this is my desired output. So once I execute this data model, I need to get this output, which is nothing but the data. So I actually have this data beforehand itself. Okay, this is the expected result. So once I build and do a unit test. So where am I doing unit test? On the development system. So on the development system, I do a unit test. And once the unit test is completed, the build phase is complete. So all this documentation has to be get ready. What is the table? What columns inside each table? Low-level design documents on how these tables are joined together, and what is the desired output. And once you test, you need to get the desired output. Then we can transport, at the later point of time, we can transport these data models from development to quality system to again perform user acceptance test. So in a when preparing a low-level design document, what are the things that are necessary? One is, what are the tables? What columns inside each table? How these tables are interrelated to each other? You also need to have one important information that is known as join type. What is the join type? I need to join these two tables. There are different types of joins in SAP HANA. One is inner join, the second one left outer join, third one referential join, fourth one right outer join, fifth one text join. So there are 5 different join types. Whenever you join two tables, we also need to tell what is the condition you want to apply on these two tables. An inner join gets common values between both these tables. Okay. We can blindly remember one point here. We can blindly remember one point. The point is, whenever you join an attribute table, why KNA1 is known as an attribute table? Because it gives more details about customer. An attribute is something which gives more details. Okay, what is customer region? What is his country? What is his phone number? What is his PIN code? So KNA1 gives more details about customer related information. So whenever you join an attribute table, when you join an attribute table with that of a text table, whenever you join an attribute table to a text table, it is text join. Now what is a text join? So when designing a low-level design document, you need to know what tables, what is the relationship between these tables, the third point is what is the join type. What is the type of join I need to give here? Now why should we take text join? What is the importance of a text join? The importance of a text join is, please see, region is 08, region is 08, or land 1 is DE. When you join land 1 of KNA1 to land 1 of T005T, you're actually joining both these columns. So when you join, what it is going to do, so here you have value DE, which is, and again here you have value D. So this D and this D, based on what condition you want to apply. Now, D is nothing but an ID. D is nothing but an ID. For this ID, what is the text? Germany. Can we have something like this? For the same ID, can you have a different text in Chinese? For the same D, can you have a different text in Japanese? Can you have in German? Can you have in French? So one ID has different text. So what is my requirement over here is, for example, I'm an English user. My name is John. I'm an English user. I'm from US. So when a John logs into system, when he's trying to log into SAP HANA, what text he need to display? He need to display English text. When a Chinese user logs in, he need to display Chinese text. When a Japanese user logs in, he need to display Japanese text. So what the text join does is, what is the importance of a text join is it dynamically filters a language column. There is a language column called, in each of these text tables, you have a column called language key, which is SPRAS. So this column SPRAS is nothing but the language key. So this language key, what it does is, so D is an ID, language is English, which is in Germany. A language in Chinese, so you'll have a separate description for Chinese. So simply to say, this table is organized like this. This table is organized like this. I'll show you practically again. I'll show you everything in practical. So you have land 1, we have SPRAS, we have land X, which is nothing but text. Land 1 is DE, land 1 is DE, land 1 is DE, language is English, language is Chinese, language is Japanese, so here you have Germany as a description. Here you have something in Chinese. Here you have something in Japanese. Now, when you try to join on DE, so you have so many D's over here. So let's say I'm an English user. So what text join does is what a text join does. So when you log into SAP system, we need to choose. Okay, I need to choose when you log on to SAP or when you log on to HANA, you need to provide login, password, and language to log in. So when you log on, you actually choose English language. When you choose English language, what a text join does is, okay, the user is logged in English, so I need to restrict on an English language and show Germany. User is logged in Chinese, I need to restrict for Chinese language. So this is done dynamically by system. Why do I have to show for an English user what is the use for me to show based on Chinese or Japanese? It's not necessary. Because all that I require is to see D in English. Okay. So tables, columns inside each table, what is the join type? Now why I need to select text join is because based on user session, the user will choose, the business will choose what is the language, English. What a text join does is, it picks the ID from KNA1, it goes to T005T, it selects the ID, the user has chosen English as his logon language, so it dynamically filters SPRAS to English and shows the description. So like this, it does for every user. Every user can see his language or in his local language by use of a text join. So simply to say, whenever you join an attribute table to a text table, always this is a text join. Whenever you join an attribute table to a text table, it's a text join because user want to see dynamically based on user session, he would like to see the language, and that can be achieved using SPRAS. SPRAS is dynamically restricted by the user. Okay, so when preparing a low-level design document, tables, columns, join types. Step number 1, choose table. Step number 2, what columns inside table. Step number 3, what is the join type. Now what is step number 4? In the step number 4, we need to choose, please see, in KNA1 table, we may have 100 columns. In T005T, we may have 10. In T005U, we may have another 10 columns. 100 plus 10 plus 10. So totally, to achieve this requirement, so how many columns I require? 1, 2, 3, 4, 5, 6. 6 columns I require. But how many columns do we have in these tables? We have more than 120 columns. Step number 4, we need to do something called minimal projection. We need to do minimal projection. What is minimal projection? What is the use of a projection? A projection is nothing but a selection of columns. We may have 120 columns inside all these 3 tables together. But based on my requirement, how many columns I require for output? So based on the business requirement, what is my expected output? What is my expected output? Only 6 columns. So I will choose, I do something called minimal projection, nothing but selection of columns. So from this table I require 4 columns. From this table I require 3 columns. From this table I require 3 columns, for example. So step number 4 is doing projection. Step number 4 is doing projection. And step number 5, and finally, do unit test and prepare sample data. So all this documentation we need to have, and we need to get a sign off from business before even we start to build the attribute view. So like this, in a given project, we may have different consultants. For example, in a project we may have 10 HANA consultants. We need to share, okay, so basically once the functional spec is completed, once the workshop is completed, we need to come with the list of master data. We need to come with the list of master data. Means, okay, this is my master data list. Customer master data, material master data, sales organization master data, distribution channels, divisions, sectors, and some master data is related to sales, some master data is related to HR, employee. So we need to share who is going to create what attribute views. So we need to maintain an Excel sheet, all the list of master data related attributes, because we may end up doing redundant work. I am creating customer master, another developer also will start creating customer master. So we need to assign, okay, this is the list of master data we have total. So who is going to create what? We need to maintain this sheet. And once we maintain this sheet, also I need to highlight few important points over here. Now, when we are designing a view, this view has tables. Okay. Now, where are these tables coming from? These tables are coming from catalog. These tables are coming from catalog. Now, what is a catalog? Catalog is nothing but it's a collection of schema. It's a collection of schema. Now, how do we organize schema? We organize based on data provisioning method. For example, in this case, let us take BODS. A schema called BODS will have these 3 tables. What are those 3 tables? It will have KNA1, it will have T005T, it will have T005U. So a catalog consists of a schema consists of these 3 tables. So tables are specific to schema. So whenever you select a table in HANA, BODS.KNA1, BODS.T005T, BODS.T005U. So, but where are we creating these attribute views? Attribute views, this attribute view we are creating where? We are creating in content. So under content, what do we have? We have package. We have package. Under these packages, we have information views. So the point I'm trying to highlight over here is we are creating an information view. We are creating an information view of type attribute views. So what is the type of information view we are creating? Attribute views. Now what is attribute view? Is to join master data tables together which are in schema. So to create this attribute view, nothing but information view, I require a package because views are organized under what? Views are organized under packages. So when we're creating a package, so how do you create a package? Based on what criteria do we create? Based on application. First, okay, the source is ECC. Under ECC we have SD. Under SD we have SD master data. So what I'm trying to say is, so now we have list of attribute views that we have to create. Nothing but, let's say this is a customer attribute. So this customer attribute I need to create. So this attribute is in which package? I need to mention this package. So sometimes what happens is, in HANA, we may have different systems together. We may have CRM, we may have ECC, we may have data from supply chain management. So these are now, we have 3 different packages, each for one source system. So in here, ECC, CRM, and SEM. Okay. There are different set of developers who work on SEM project, different set of people who work on CRM project, different set of developers who work on ECC project. So what I'm trying to say, developer 1, a developer 2, a developer 3. So we have 3 developers. Each developer is working on different systems, on different applications. So the HANA administrator, what a HANA admin does is, he actually restricts this package only need to access by this developer. This package needs to access by this developer. This package needs to access by this developer. So in a multi-user environment, in a multi-developer environment, we actually restrict packages to the developer. This is known as package privilege. We restrict packages to each developers. So whatever a developer is doing work on one package, another developer may not be able to access the package. In order to access packages together, we need to have package privilege. So using a package privilege, when you have multiple developers, for example, on SD master data, I have 100 information views. For 100 information views, a single developer cannot create. Probably we require 3 or 4 developers. So all these 3 or 4 developers will have access to this package. So this is known as a package privilege. So what packages need to be assigned to what developers, that document also, we need to make it ready. And this will be taken care by HANA administrator. So basically, we have 2 roles. One is HANA administrator, the other one is HANA development or an HANA application consultant. So most of the time, our focus will be on the development side, creating of views, attribute views, analytic views, and calculation views, designing these documents, doing unit test, developing these data models, performing user acceptance test, and then transporting to production. So all these activities, data provisioning, data reporting, everything is part of the HANA application consultant. Installing of system, maintenance of system, authorizing what developers need to have access to what packages, all these things will be taken care by HANA administrators. But in this course, what we are going to see, we're going to see both. So mostly my focus is on the HANA application consultant. And I'm also going to cover 50% of the administration. Now why administration will be useful for us is, especially in the senior level, like solution architects, senior consultants, we'll have to have an idea of even the HANA admin side, sizing of the system. So first, now my first focus is on the development, and that too, I'm going to focus on the information views. So information views, these classes will take around, to complete, it takes around 15 to 17 sessions. Only completely will be on the data modeling. So once we complete data modeling, then I'll move on to data provisioning, how to provision data from one system to a different system, how to use SLT, how to use BODS, and finally to the reporting, and then user management, and then HANA administration, how to install SAP HANA, and then BW powered by HANA, and then S4 HANA. So whatever the work I'm going to do, anything that is related to project, I'll actually deliver during the course itself. And finally, we basically look into certification questions, interview questions, what are the different kinds of errors we may face on a daily basis. In each support pack, what errors we got, how did we resolve those errors, we'll see at the end of these sessions. So now, this is the whole idea of this course. So let us log into system now. Let us log into system to see whatever the requirement I have. Let us log into system and see now. The username is Surya and the password is so now I'm in the remote desktop connection. So once we are inside the remote desktop, I'll click on Start, click All Programs, click SAP HANA folder, click on the HANA Studio. So we'll see now very organized way on how to create these attribute views, step-by-step process. Click OK. So once we log into HANA Studio, right click on the system, log on to SAP HANA, provide the password, and click OK. Now here you have catalog. Expand the catalog. Under the catalog we have HANA user schema. Expand the schema. The schema is HANA user. Under schema we have tables. Expand tables. In here, based on my requirement, let us see whether we have these tables. I have KNA1. I have T005T. So do I have T005T? Yes. Do I have T005U? Yes, I have. So let us preview contents of these tables. Let us see contents of these tables. Right click on KNA1 and open data preview and click open data preview. So this is the contents of KNA1 table. And let's go to T005T. So what is T005T? It is country text table. Right click on the country text table and open data preview. Please see here, the LandX column, here you have SPRES, nothing but the language key, land1, which is nothing but the ID of the country, and this is the description of these countries. So you see, you have different languages, like Chinese you have English, you have German, you have Japanese language. So all these different languages we have in T005T. And 5U is nothing but the region description table. It's the region description table. Okay. Now you may have one doubt over here. The doubt is, how did I get these tables to HANA user schema? How did I get these tables to HANA user schema? So just to clear the doubt, so we have HANA user schema. Under HANA user schema, you have three tables, KNA1, T005T, and T005U. These three tables store data in columnar fashion. They are storing data in memory. Now, there are two scenarios over here. Scenario 1 is known as sidecar scenario. Scenario 1 is known as sidecar scenario. Scenario 2 is known as main car scenario. Sidecar. First, let us see a sidecar scenario. Sorry. And then main car scenario. Now, what is the difference between a sidecar scenario and main car? In sidecar scenario, we have ECC as our source system. Let's try to reduce the font. We have ECC as our source system, and we have HANA as our target system. Now, what is the origin of these three tables? So based on my requirement, origin of these three tables is on the ECC side. So where are these three tables? They're on the ECC side. So these tables belong to ECC. Please see. I'll click Start, click All Program, click SAP Frontend, SAP Logon. I'm logging into ECC system. So here I have ECC 6.0 EHP7. Double click on ECC 6.0 EHP7. User is Surya. Surya1234 is the password. User ID and password. Let us click enter. Once I enter, please see the ECC system that we have. Click Systems, click Status. The ECC system that we have is on, what is the database here? MS SQL. Okay. ECC system is basically storing data on MS SQL system. So what is my requirement here? I need to take these tables from MS SQL to HANA. To where, in HANA, where I need to take to HANA, I need to take to the schema called HANA user. And inside the schema, in the catalog, I need to have these tables. Now, how can I take this table from ECC to HANA? Using SLT or BODS. Okay. Now, how did I get these tables here? How did I get these tables to HANA user? How did I get this to tables folder? So just to tell you, I got this table from ECC, which is on MS SQL, to HANA using BODS. So that is how I got these three tables to HANA. So the scenario that we are seeing now is a sidecar scenario. So ECC is on MS SQL and HANA is the target system. So we got this table from ECC and I put these tables in schema called HANA user schema. So how did we get these tables to HANA user? Using BODS. But I'm not showing this exercise on how I'm actually getting these tables. All that I'm actually telling here is we already have these tables in HANA user. Because I already replicated these tables. from ECC to HANA using BODS. So when will we see this exercise? Once we complete data modeling. Once we complete data modeling, we're going to see that exercises. Because that comes under part of data provisioning, but my focus now is data modeling. Now, we got these tables to HANA user schema. Now, once I have these tables, what is the next thing that I need to do? We have tables. We need to start building attribute views. We need to start building this attribute views. So how do I start building these attribute views? Based on the documentation. So already I created a document over here. So these three tables I require, KNA1 T005U5T. I got these three tables using BODS to HANA user schema. And then I need to start creating this attribute view called AT customer. So where do I create attribute views? Attribute views are created in content. So in the catalog, you have schema, you have these tables. In the content, we have packages. In the package, we have information views. So yesterday, we created one package. So let us go to the package. So I'll go to package. I'll go to the HANA Studio. I'll go to the HANA Studio. I'll go to HANA Studio. Here we have content, expand content. Yesterday we created one package called ECC March 8th is the package I created. So see how many packages we have. We have a lot of packages. So each of these packages should be restricted to different developers. So how this restriction happens on each package? Please see. So all these are different packages I have. So here you see security folder. Under security folder, if you expand the security folder, here you see users folder. If you expand this users folder, here you see this is one user. Okay, the username is, let us say, Vijaya or Venu. Venu is one user. So this Venu user has package privilege. So in here, the HANA admin will actually tell, okay, this Venu can have access to ECC March. Is actually doing a search. So this user Venu can have access to these following packages. So actually I can restrict this package. When you give something called root package, he can access all the packages. Everything he can access if you give root. So I'm not giving root, I'm only giving, okay, I can access this package called ECC EMC FICO. So this is the only package when you can access. So here I can do package privilege. So when you're working on a real world, every developer will have his own user ID. In his own user ID, he can see only limited set of packages and limited set of schemas. It's got closed. Let me reopen HANA Studio. HANA Studio got closed. Just give me 1 second, please. Just give me 1 second. Yeah, sorry. The plug was switched off. So in here, let me open the HANA Studio. So from the system, so in the security we can use, so the security we can see what users have access to what package. So now I'll go to the content folder. I'll expand the content folder and go to the package and go to the package. So I'm going to create attribute view for customer. So right click on the package, click new, click attribute view. Click on the attribute view. So let us give the name for an attribute view. So what is the name? So we need to see the documentation. So what is the name I need to give? We need to strictly follow the documentation that is given or we prepared or it is given from the on-site. So the name is AT customer. Why AT? AT means attribute view, SAP standard naming convention. But it is not mandatory to start in ABAP. Usually we start with Z or Y. So it is not mandatory to start with AT. You can start anything, but best practice is to start with AT. So I'll go back to the system. I'll go back to the system and I'll start to create AT underscore customer. This is the name and this is the label. So name of technical name and the label. So what is this? This is an information view. Information views are how many types? View type, attribute view, analytic view, calculation view. So we have three view types. Let us select attribute view. Again in attribute view, again inside an attribute view, we have three subtypes. Standard, the second one is time, and the third one is derived. So by default, today, let us see what is standard attribute view. So standard is a subtype of an attribute view. So how many information view types? We have three information view types: attribute view, analytic view, calculation view. Again, inside an attribute view, we have three subtypes: standard, time, and derived. Time is for time-based attribute views. Derived is an alias, is a reference attribute view. So tomorrow we focus on time and derived, but just I continue with standard. So I'll go to the standard and click finish. I'll select standard and click finish. So once I click finish, so here you see scenario pane. In the scenario pane, you see semantics. Under semantics, we see data foundation. Click on the data foundation. Once we click on the data foundation, details pane, output pane, properties pane, scenario pane. So this is one tab. A new tab is open. This is just like Google Chrome. So this is one tab. In the tab, what is the package name and what is the view name? And what is the username? The user is HANA user. So under scenario, you see two important things. One is the semantics. Once I click semantics, the screen change. Once I click on the data foundation, the screen change. Okay. Now, what is a data foundation? A data foundation is an area to define a relationship between tables. So how many tables I have over here? I have 3 tables. So click on the plus icon, add objects. So click add object. So what is the table name? Table name is KNA1. So I'll enter the table name KNA1. The KNA1, you see, KNA1 is an SAP ABAP 1 and KNA1 is in HANA user schema. So same table is actually available in 2 different schemas. So this is for main car scenario. So I showed you one scenario called, we were about to see one scenario called main car. In main car, the application itself is powered by HANA. That is known as S4 HANA. So this is for S4 HANA and this is for sidecar scenario. So what is my requirement here? What solution I'm designing? I'm designing a solution for sidecar. So KNA1 from HANA user. So tables are specific to schema. Tables are specific to schema. So I'll double click on table. I'll double click on KNA1 table. Please see. When I double click on KNA1 table, at the data foundation you have HANA user.kna1 table. So you see these are different columns that are available in KNA1. I'll click on the plus icon again. I'll click on the plus icon again. I'll add other tables as well. So what is my second table? T005T. So I'll type in T005T from HANA user, and click OK. So here you see the second table as well. So what is my third table? The third table is T005U. So like this, based on the documentation, so this work is mostly done by the junior consultants. Like people, if for example, now HANA is around 3 to 4 years old. In India, especially in India or in US, most of the projects that are executed in 3 to 4 years span. Initially, when it is released, there were around a few handful of customers, but most of the projects which implemented is on 2013, 14, and 15. Okay, so this work, what I'm doing now, will be done by consultants who are 1 year, 2 years, and 3 years HANA consultants. So most of the senior consultants will work on the document preparation, preparing of these documents and giving these documents to the consultants who can work on the system. So there are people who prepare documents, there are people who actually work on system. Sometimes, especially when we are working on on-site, like directly on the client side, both these activities we only have to do, preparing of documents and designing the solution. Sometimes it is on-site offshore model. On on-site, mostly at the client location, we take the requirement, we keep continuously interacting with the business. And in the offshore, most of the time, people don't have access to business, they have access to these documents. So based on these documents, they have to start building the solution. So what am I trying to do now? Based on the document, I'm just trying to build the solution, which is the document is already prepared. So KNA1, T005T, and T005U from HANA user, and click OK. So now we have these 3 tables. So what is the next step? Step number 1, add tables. Either you can add tables at the data foundation, or I'll delete this. If you want to delete a table, just right click on the table and remove. Click yes. Click on the free space. Click add. You can add from here also. T005T. I can add from here also. Click OK. So here you can see T005T again. Again, I'm trying to delete. Again, I remove, click yes. I can add in a different way as well. I can go to the catalog, expand the catalog, expand the schema, HANA user schema, expand tables, T005T, select the table and drag and drop. Like this also we can add. So either you can add tables at the data foundation at the plus icon, right click on the free space to add tables, or you can just select the table and drag and drop to the data foundation. So step number 1 is completed. Based on the business requirement, I selected these 3 tables. Now these 3 tables I'm creating an attribute view. Now what is the next step? Step number 2. Define relationship between tables. So what is the relationship between KNA1 and T005T? What is the relation? Join land1 to land1. What is the relation between KNA1 and T005U? Join regio to bland. Now, once you actually join, once you define the relationship between tables, what is step number 3? Step number 3 is to define join type. Select the join. Once you select the join, in the properties of the join, you see there's something called join type. So what are the different types of joins? Referential join, inner join, left outer join, right outer join, and text join. So there are 5 join types. Now what join should we select over here? We have an attribute table, we have a text table. What is the join type? Text join. So whenever we select a text join, the language should be SPRAS, which is nothing but language column. Why should we select language column? Please see. Why should we select language column? Now, whenever I log into HANA system, now what is the user here? HANA user. When I right click on this system, when I click properties, when I click additional properties, here you see logon language. So what is the logon language that this user is logged to HANA? English. Now what are the other languages you have? You have Chinese, you have all other languages, Japanese, Malay, Portuguese. But what is my requirement? My requirement is HANA user is an English user. So when I give spras, what is this spras going to do? What is this language column going to do? It is going to check, okay, this user is logged in English. This user is logged in English. So I need to display text in this table only in English. Please see, when I right click on the table and click data preview, when I click data preview, I can actually view table directly from the view. I don't have to navigate back to the schema. I can just go here, right click on the table and data preview. Please check over here. When I click on distinct values, distinct values, what it is going to do is, it is going to show all the values from a column. When I click on SPRAS, which is language column, so here these are different language I have in this SPRAS. So this is the count of records. For English language, I have 257 values or the descriptions that are in English. So 257 countries are there in English. So if you click on raw data, it's actually showing everything. If you basically go to SPRAS and add filter, Let me add filter and click on show list of values and select English and OK and execute. So you see all these are English, this is language key, and these are descriptions. Okay, so what I'm trying to show you here is whenever a user is logged in English, it system automatically filters. So here I'm doing, or here I'm showing manually, but system automatically filters on this language and show descriptions in English. So the third step, step number 1, add tables. Step number 2, define relationship between tables. Step number 3, define join type, which is text join. So I'm going to continue this exercise tomorrow as well. Tomorrow I'm going to continue this exercise, but today I'll just try to recap what we have seen in today's session. In today's session, I was continuing the yesterday's session. In the yesterday's session, we just created until the functional spec. We have taken the requirement. So based on the requirement in today's session, we try to identify what tables, inside each table, what columns. Nothing but the technical spec. Once the technical spec is ready, we design low-level design document. In the low-level design document, we try to identify or design the attribute view. So what are tables? What is the relationship between each table? What is the join type? What are the field selections for output? And finally, unit test. So once we actually designed for one of the information view, and then I started to show you, then we started to see in a sidecar scenario how we are actually going to get these tables. So we're going to get these tables using BODS. Tables are on the ECC side. Using BODS, I can get to HANA. So once you get to HANA, where are these tables available? Under catalog, under schema, you have these tables. So once I have required tables, based on the business requirement, I will get all the tables. So once I actually have these tables, I'll start to create an attribute view. Attribute views are used to join master data tables. So I provide the name, I provide the description, view type is standard, and then what is a data foundation? A data foundation is a place to join tables together. And semantics is nothing but an output. Output of the data foundation is nothing but the semantics. So when creating an attribute view, step number 1 is to add tables. Step number 2 is to define a relationship between tables. Step number 3 is to define join type. We haven't completed this exercise. We're actually in the middle of the exercise. But due to the time is completed, we have taken more than 1.5 hour session. I would like to just end the session. Probably other participants may have to leave for the other work. So I'll just stop this session. I would love to complete, but tomorrow I continue this exercise and we'll see the output for this exercise. Thank you everyone for your patience to attend today's session and for your time, and have a good day, good evening and good morning to everyone. Please type in your questions in the chat box. I'll quickly review questions in the chat box, answer to those questions. If any participants want to talk to me, please raise your hands. I'll unmute, you can ask questions. Also, you can post your questions on the email whenever it is possible. Or if you want to talk to me personally, you can always call Bharat and ask him to conference call. So usually I'm free from evening 6:30 p.m. till 8 p.m. So usually I'm free that time. If any participant want to talk to me, you can call Bharat to conference call. He'll actually connect me through the call. So first we will actually see the questions now. I'll start reading the questions one by one. So the first question here we have here is the system know a table is a column type or a row type? So actually, if you see, whenever we replicate tables in HANA, by default, always system prefer to replicate as a column store. But we can change from a column store to a row store. By default, it takes as a column store, but we can change from column to, so default selection is column, but we can change to row. So next question. If you want to change from row to column, is it possible? Column to row or row to column is always possible, but it drops the existing table and recreates the table when you're doing the data provisioning. So it basically drops and recreates the table as desired. Next question. A Z table is created in SAP ECC system. I have access to the system the system in HANA. Which type the HANA system will take either row or a column? I have a Z table created in ECC. Okay. So the question here is, I'll try to reframe the question. Whenever you have ECC system powered by SAP HANA, when you have ECC system powered by SAP HANA, the question is whether the system will have the Z table, whatever the table that a developer created, will it be stored as row or a column? That is the question. If that was the question, the answer is, as we discussed, by default, system takes it as a column table. Next question. So questions from yesterday's class. So can we say in HANA, metadata, master data are in row-based tables and transaction data are in column-based tables? Here's small clarification I want to make. Metadata is nothing but data about data. When we talk about metadata, what is metadata? Metadata is nothing but the container, nothing but the data type and length of data. So the metadata, tables container information is stored in row-based tables. Now why tables container information is stored in row-based tables? Because metadata is nothing but system data. Metadata is a system data. But the actual data is stored in column-based. The container information is also stored in different tables. That is a row-based table, but the business data is stored in column-based tables. Next question. What means the country name stores in different language in T005 view? So when I say country name stores in different language in T005 view, it means that SPRAS is the language column that differentiates between each description. This description is in English. Now how does system know this description is in English? In SPRAS, you see, the value English is actually indicating that this name is in English. If it is in Chinese, the description is in Chinese. So what means that country name stores in different languages in T005 view is nothing but SPRAS is the column that differentiates languages of these descriptions. Next question. How it dynamically picks language based on the user session? Don't we need to do anything at the background to bind language manually? Yes, we have to bind language manually. That's why you see here in the language column, I try to bind the language column, SPRAS. So when I bind this, system based on the user session will actually identify what is the language. The next question, let us see the next question. If the system takes care automatically with the language select at log on, why it will make different if I use an inner join instead of a text join? Good question. So what is the difference between a text join and inner join is text join additionally does one more thing here. Now if you take an inner join, what happens? Please see, if you take an inner join, I think I drew somewhere here. Now if you take an inner join, please see, so inner join what it does, it takes common values. So D is here, when you do it, instead of text join, you do inner join. So it will give all the three values to the output. Because D, it will take three entries. So instead of showing one entry, because additionally what text join does is, it filters on the language column. But if you take inner join, all three will show the output. So three descriptions will be shown in the output. If you have 50 descriptions, all the 50 descriptions will be shown in the output. But my requirement here is, based on the user session, I need to see the descriptions. So obviously, additionally, the difference between an inner join and a text join is inner join only gets common values, but text join dynamically filters on the language key. Let us go to the next one. Let us go to the next question. How to determine when to use a sidecar scenario and when to use a main car scenario? A simple thing would be when to determine going a main car, when to go for a sidecar. If the budget is very less for a project, for example, if you have a million tables on the source system, if you have a million tables on the source system and you have a limited set of functionality you want to implement in HANA, you don't want the entire database should be on HANA. But you only want, based on the requirement, I only want this set of requirements in HANA. Then go for sidecar. So in sidecar, we will not have all the tables of the source system on HANA. We'll have only set of tables that we replicate. So limited functionality. If you want the entire system to be on HANA, go for main car scenario. Means the investment is very high in main car because the entire system is on SAP HANA. So if you have limited functionality, limited requirement, go for sidecar. If you want the entire system to be on HANA, go for main car scenario. Next question. Sidecar and main car, are these HANA industry terms, or can we use them in projects? These are actually used in the industry. When the SAP basically talks about any solution, they say sidecar or main car. Main car means the application is powered by HANA. Sidecar means the application is not powered by HANA, but it is on the side of the existing solution. That's called a sidecar scenario. Next question. In BI and BW, we have data warehousing in that. We have info areas, info cube, multi-provider data sources, and store data accordingly. The question is not complete over here. Only partially the question is written. Please, please type in. Please type in. question completely. When Hadoop can deal with structured, unstructured, why can't we do this data analysis instead of HANA? Why can't we do this data analysis instead of HANA, as it only deals with structured and semi-structured? I'll read the question again. When Hadoop can deal with structured and unstructured, why can't we do this data analysis instead of HANA, as it only deals with structured and semi-structured? Okay. Now Hadoop it's not an SAP product, and we cannot have Hadoop directly on ECC. Means SAP solutions are designed in such a way they can take the advantage of SAP HANA. So SAP HANA is an in-memory database from SAP, and even the applications are powered by SAP. So SAP applications in HANA have a very tight integration. So SAP application can complement HANA, HANA can complement SAP application. But Hadoop is something which is an open source, which is not designed for SAP. But still, we take advantage of Hadoop only for a limited set of functionality, especially for unstructured data. HANA is an in-memory database, but Hadoop, the advantage of Hadoop is it is actually a file system. Hadoop can also process data parallelly, HANA can also process data parallelly. But Hadoop is not an in-memory solution, it is based on disk. It is a disk-based solution. But HANA is an in-memory solution. It is primarily storing data in memory. So the difference is Hadoop is mainly designed for big data solutions where you have terabytes of data. When you want to crunch terabytes of data, that too semi and unstructured data. But HANA mostly, because SAP mostly stores data in the form of tables. You see, most of the SAP applications are basically storing in tables. So in that case, Hadoop is not designed for relational RDBMS. It is mainly based for text-based analysis, or it's a file system. So based on the SAP applications, HANA is most suitable. But still, whenever you want to design, whenever you have a specific requirement to deal with semi-structured data, then in those cases, we still can continue to integrate Hadoop with HANA. So these are the questions we have in the chat box. So today I'll end the session here because sorry for today delay. The session is extended. I'll try to close on time. Thank you for your patience to be until now, and surely I will try to close on time. Thank you. Thank you everyone to attend today's session. I'll see you tomorrow, same time. Have a good day to everyone. Good morning and good evening to everyone. Thank you.